Hi, I'm Calvis Rice, and I'm the Director of Business Development at IPS. In this presentation, we're going to talk about our product line that deals specifically with tooling surface finish. We developed this product line because tooling surface finish matters, and for bodymaker tooling to perform well, surface finish cannot be ignored. This is the same for necker tooling, which is why we have created these three products to address surface finish of tooling. All of our products were created because of a specific problem. So let's talk about why somebody should crosshatch. So for a successful ironing process inside of the body maker, it is important that there is the correct amount of friction between the punch and the can wall. With not enough friction, tear-offs will be the result. And so the friction needs to be applied to the punch. And the optimal crosshatch has an angle that helps the stripping process, and it also removes aluminum oxide from the punch surface. At this point, we always talk about the customer needs, and depending on what the customer is currently using, there is always an opportunity. So it's good to understand what the customer is currently doing to add a surface finish to their punches. Now, the answer may vary widely. One answer may be they're not currently applying any sort of surface finish to their punch, and typically in this case, they are having lots and lots of tear-offs. If they are applying a surface finish, it could be doing cross-hatching by hand, which means that there's opportunity to do it better, or they could be using an old crosshatch machine not designed or built by IPS. And again, there are opportunities for improvement by moving to the IPS gauge. And depending on the solution, there will always be pain points that they currently have. And typically, the main pain point is tear-offs inside of the body maker or short cans inside of the body maker. This is the X2 crosshatch machine, and it is an automated crosshatch machine specifically for the can manufacturing industry. This machine has become the industry standard. There are over 100 machines in the field globally, and it is a model of consistency and performance. One of the main reasons that the X2 is such a great performing machine is that it eliminates operator influence for the crosshatch. So it controls all of the important variables, including the application pressure, and it does this by having a air pressure regulator. It controls the crosshatch angle, and it does this by having a PLC that controls the program, and there's different programs for different size punches. And it also controls the liftoff points. So you do not want a crosshatch on the punch nose, for example, so it's important that the liftoff point is controlled, and this is done based on these adjustable cams right here. And we'll show you in a moment a video of how crosshatching looks. Finally, we control the surface roughness. And so the surface roughness on the punch is controlled really by two different variables. One, it is the pressure at which we press down on the punch, but also IPS provides various grades of diamond media that give different surface roughnesses, and it's important to have control over this because not all can plants run the same, so it's important to have the ability to slightly modify or fine-tune your crosshatch, and the X2 gives you this capability. The X2 allows you to fine-tune the crosshatch to your specific plant, and once this is done, it allows you to set all of the variables so every single user that crosshatches a punch does it the exact same way. We also have another video that goes over the science of tear-off reduction, and it goes into lots and lots of interesting details about tear-offs inside of the bodymaker and why the crosshatch is such a good solution for them. In this video here, we're going to show you how the crosshatch actually looks on the X2. So you'll see three important things. You'll see the punch turning, you'll see the back and forth motion of the crosshatch, and you'll also see pause times on either end. And those pause times are important because the crosshatch that the X2 provides is uniform around the entire punch. And so the pause times make sure that just like on the threads of a screw, that the crosshatch pattern is built upon. And so when the crosshatch is complete, there is not more or less crosshatch on any portion of the punch. It is consistent around the entire surface of the punch. Two other important things to look at is that this is how a crosshatch looks when magnified, and the angle is very important. We recommend a starting angle of 60 degrees, and so this is pre-programmed into the machine for every single punch when a customer buys the crosshatch machine. But we do have the ability to adjust angles, and the recommended range is between 40 and 60 degrees. Again, the science of tear-off reduction video will go into the details of why that is the case, but 60 degrees is a good starting place. Another thing worth pointing out is that we're continually improving our equipment, and on the X2 crosshatch machine, that means that about a year ago, we added a brand new standard feature, which is an auto media feed. And so in this image here, we see that this red ribbon here, this is the diamond media. And this assembly right here is the auto media feed. What it does is that after every single punch, we have the capability to automatically index the crosshatch media. And so what this does is it assures that every single punch will have the same crosshatch media quality available to provide the surface finish. And so typical administrators will set the parameters to index about 1/8 of an inch every 2 to 3 punches. And so this makes sure that first, there is always fresh media available for each individual punch, but it also assures that users don't have the flexibility to pull too much diamond media out and waste it. So to conclude, the X2 has a number of benefits. The most important is it is the most controlled crosshatch application available on the market. It is consistent and it is repeatable. And the main reason to crosshatch is, of course, reducing bodymaker tear-offs. And finally, by controlling all of the variables, we are able to fine-tune individual parameters to plant level optimization. The next piece of equipment we'll talk about has to do with removing aluminum pickup. So why did we design this piece of equipment? Well, aluminum pickup on necking dies causes back-end performance issues in the necker, and aluminum pickup on bodymaker tooling causes front-end performance issues in the bodymaker. So it's important to address aluminum pickup as efficiently and effectively as possible. So customers typically will have some sort of a solution for removing aluminum pickup. And typically this falls into one of two categories. Either customers will have some sort of an ultrasonic cleaner that uses caustic solution, And these typically are not standardized from plant to plant, and usually it just sits on a bench somewhere and may be causing problems because it is old or messy or simply no longer works. That's one solution. Other solutions are plants that will put their tooling into a speed lathe and use an abrasive to remove the aluminum from their tooling. And although this may seem to work and get their equipment back up and running, the problem with abrasive is that if you are removing aluminum from the tool, very likely you are also affecting the surface finish, or even worse, the profile of the tool at the same time. So we highly recommend not using abrasives to remove aluminum pickup from tooling. This is called the tool clean offered by IPS, and it is an ultrasonic tool cleaning system. Ultrasonic uses heat, vibration, and caustic solution, and it has a controlled heating and timing cycle. It also has an integrated cleaning, rinsing, and drying stations. And finally, it is of stainless steel to hold up the plant use and the caustic solution. So let's look at this a bit more detail. So this is the ultrasonic station right here, and both of these lids can come off. And so in the ultrasonic station, here we have the control panel which controls the temperature, and that is the heat in the ultrasonic cleaning system. And it also has a timer, and the timer tells the system how long it will vibrate, and the vibration is the actual ultrasonic portion of the cleaning. So we control the heat and we control the duration. Now, there is a basket on the inside of this ultrasonic cleaner that allows multiple tools to be cleaned at the same time. Typically, a cleaning cycle will take 5 minutes or less, and being able to clean multiple tools in less than 5 minutes is very, very nice in the can plant. So after the tools are removed, the basket is placed directly here, which is a simple rinse tank. And after the rinse tank, they're placed on the drying rack. It's important to point out that we always recommend towel drying the tools after they come out of the rinse station. It's important to get any water or residual caustic solution off of the tool as soon as possible. But the stainless steel design here holds up to the caustic chemicals, and it is a nice standard way to perform ultrasonic tool cleaning at the plant, and it is ready to go right out of the box. So in these videos, we'll show you a couple of examples of carbide necking tools before and after. We've also performed tests and created videos of very extreme examples of aluminum pickup on bodymaker punches. And it's amazing how quickly the aluminum disappears through the ultrasonic cleaning process. The main benefits of the tool clean include zero effect on tooling geometry, meaning that with the caustic chemicals, you can actually clean tool steel, carbide, and ceramic, and it will not affect any of those materials, only removing the aluminum. It's a repeatable process, so the aim is always to standardize these processes. So by controlling the heat, and the time with a defined solution of caustic chemicals is truly a repeatable process. And finally, it's a time savings. So by cleaning batches of tools in only 5 minutes, it is much more efficient than putting individual tools on a speed lathe, for example, and cleaning up each one individually. The final product that we'll talk about in this presentation addresses polishing punches and dies. So why was this created? Why is there a need to polish punches and dies? Well, polished punch noses allow for a smooth drawing process around the dome of the can. So if you notice punches, they always have nice and shiny punch noses. That's very important in the actual dome forming process. And redraw dies are polished to aid in the can redraw process. So when the cup drops into the body maker, the first forming process is the cup going through the redraw die. And so it's very important that the redraw die is nice and polished to help in the can forming process. So customers typically have a way to polish punches and dies, and the most common way this is done is by a speed lathe with a universal three-jaw chuck. And so the pain points are typically having to do with a three-jaw chuck is very dangerous when working on a speed lathe, especially when trying to polish something like a redraw die. And so if the three-jaw chuck comes in contact with somebody's hand, it can cause great damage and is a safety issue at the plant. And also, adjusting three-jaw chucks for different type of tools is not always as easy as the user would like. So IPS created what we call the tool polish, and it is a punch and die polishing lathe. The big thing about this is that we have quick load fixtures that are designed for safety. So as you notice here, this is the die collet or die holding fixture, and there are no knuckle busters or portions of the fixture that will damage or injure the user. So it is a nice smooth surface so that the user can go and polish the die without worrying about safety in damaging their hands. So it's a variable speed lathe going from 500 to 2000 RPMs. And in this video, we will show you what it looks like to change out a die from the fixture. So we'll take a die and we'll simply place it inside of the fixture. And in the center, there is a bolt that tightens the collet around the outside of the die. And it's very simple, just like that. And there is a similar fixture for the punch. This is an arbor, and it's the same tool that is used to tighten the bolt at the center of the arbor, and it is an expanding mandrel that grips the inside of the punch. So very easy to use. And again, to recap the main benefits of the tool polish, first, it's a safer fixture design when compared to three-jaw chucks. The fixtures are designed to be quick and easy to use, changing between punches and dies. And one of the main benefits is that it's an all-in-one system designed by IPS for immediate use. You receive this at your plant and you can take it out and begin using it immediately. We always like to answer all of our customers' questions about any of the products that you saw here today. Know that there is an additional video available for the X2 Crosshatch machine titled The Science of Tear-Off Reductions. So if there are any questions, IPS is always here to answer them. Thanks for watching.